Okay, decide to quick record the quiz preview. Quiz 2. All right, so we drew a picture representing the basketball player. The angle of elevation of the sun is when, an angle that opens up from a horizontal towards the sun. So we set it up as the tangent of x, the angle, equals the opposite over the adjacent. And yes, that's exaggeration here. Second, you're going to calculate it by hitting the second, remember? Second tangent, 6 divided by 7.8. What the heck? Where'd that come from? I think I'll just start with a fresh screen. Okay, second tangent, 6 divided by 7.8. All right, 37.6 degrees. Ay, my brain. All right, so that's the angle of elevation of the sun in this situation. From the top of the school, you spot your car at an angle of depression of 41 degrees. If your eyes, I do not know what all that is, but if your eyes are exactly 78 meters up, how far away is your car from you? All right, so I don't know why you're up on top of the school, but that's what it said. And why you would be sitting on top of the school, don't know, but there you are. We'll make another kid. All right, so he's looking down at his car. Yep, sort of like a slug bug. Whoa, that's a pretty weird looking car. All right, back window. Okay. So he's looking down at an angle of depression of 41 degrees. So that's like your horizontal line coming out from your head, and then that opens downward. Now it says his eyes are exactly 78 meters up. So that would be the vertical distance from here to here. All right, and then it says, how far away is your car from you? Where's that going to go? Yes, you're up there, so that would be to the hypotenuse. All right, and this a horse. All right, we are hoping our building is standing at a right angle with the ground. What about, yeah, it's not the leaning. I know mine's a little crooked. 41 degrees, where else can I put 41? Because of alternate interior angles theorem. All right, so now we've got opposite and hypotenuse. We're going to be using the sine. So the sine of 41 equals 78 over x. Careful in your calculations because if you treat this like cross products, then you get x times the sine of 41 equals 78. And then, bless you, you would divide by the sine of 41. All right, so that's what we'll type. I know, I did not make a very nice looking school, but I don't have time. Well, what was that, 41? 118.9 meters. Oh, someone's in your car. I'm sorry. All right, the sides of a parallelogram have lengths of 18 and 27. And one angle is 38 degrees. I'm thinking that must be the acute angle, right? All right, find the length of the longer diagonal and use the law of cosines. Well, do you remember something about the consecutive angles of a parallelogram? Yes, come. They are supplementary. Consecutive angles are supplementary. So what's that angle in the corner? 180, oh, I don't know what I'm writing here. 180 minus 38, it's 142 degrees right there. All right, the question is saying to you, find the length of the longer diagonal. So that would be this one. So I want to find this. All right. So now I need to use law of cosines. So x squared is equal to adjacent sides 18 and 27 squared. Add those. Minus 2 times 18 times 27 times the cosine of 142. Okay, type that into your calculator. Let's look at my key. It's like, oh, I'm sure you guys will know how to type that in. When I did it before, I got 1,818.94. All right, and then we need to take the square root of that. And I got about 42.6 feet. Anybody need me to help with the calculation part? Type it in? No? Okay. Draw the following angles in standard position. And standard position means off of the positive x-axis. Everyone should have an initial side from here. If that initial side is where you start and you're drawing 265, then I want to see you go around, past 180, almost to 270. Okay, so that's 265 degrees. Show me you know what direction that you went. That would be enough. That's sufficient. 7 pi over 4, we have not learned the unit circle yet, so therefore we may not realize where 7 pi over 4 is. So you may wish to convert this first back to degrees. The conversion factor is 180 over pi because you want degrees to be in your answer. So pi's cancel out. 45 times 7, is that 315? All right, so that makes you think about where your angle is. That would be in quadrant 4. So that's your 7 pi over 4. Okay, and of course this was the initial side. Number 6 is negative 280. Your initial side is still the positive x-axis, but this one's going negative. So we're going down 180, then another 100 would be 10 degrees past that vertical. And this would be drawing that angle. Okay, negative 2 pi over 3. Again, you may wish to convert that back to degrees so that you can think about where that would be. 3 goes into 180, 60 times 2 times 60, it's negative 120. So our initial side, again, the positive x-axis, negative 120 would put us in quadrant 3. Okay, any questions about anything up through 7 at this point? Yes. That's not a big deal, as long as you show me that direction and the terminal side. Those two? Number 1 and 2. Okay, and 2. You're welcome. All right, convert the following to either radians or degrees. We already practiced that on the last couple of questions. The conversion factor, multiply by pi over 180 if you want degrees to cancel out. And then you should do this in a reduced fraction form. So I'm going to get 7 pi over 9 times pi over 180 for this one. Just go ahead, 5 pi over 4. Questions about that? Yes. Yes, I want it exact, not decimal. So you mean like you could get a decimal if you type that out? Yes, no, that I'd just as soon have in fraction form. Definitely fractions. All right, 3 pi over 4, we're going to convert to degrees by multiplying by 180 over pi. The pi's cancel out. 4 goes into 180, actually 45 times. 3 times 45 would be 135 degrees. Multiply this by 180 over pi. Pi's cancel out. 3 goes into 180 60 times 5 times 60, 300 degrees. All right, I believe we're on side 2 now. Worksheet for this will be on 15B. Find one positive and one negative coterminal angle for the following. So we're going to add or subtract 360. If I add 360, I get what, 605? And if I subtract 360, I get negative 115. Now on this one, we're going to have to subtract more than once. If I subtract 360 once and then twice, see what we got. So subtracting 360 gives me 420. If I subtract 360 again, I'm going to get 60. If I subtract 360 again, I'm just doing it repeatedly, I'm going to get negative 300. You need to get to where you get a negative angle. You could have also added 360 and had a bigger one, but why do that when you already got a positive one getting down to the negative one, you know? Uh oh, confusion? Pardon me? Whatever one you want. Well, if you add 360, you're just going to get 1040. You just need one positive and one negative. You can keep going all day. Yeah, I just said, well, if you got, it's going to, okay. If you're over 360, isn't it kind of clear to get to a negative one, you're going to have to do it more than once. So you might as well write down one of the ones in between for your positive one. I don't care what you had. If you added 360, you would have this one. But you've got to have this answer, or I can keep going. Negative 660. You just got to have one of each. That's it. Okay? Negative 3 pi over 4. We have to add or subtract 2 pi. Your answer has to be in radians. So what I do is I convert 2 pi into fourths. Multiply by 4, you get 8 pi. Okay, now I'm just going to do it. Negative 3 pi plus 8 pi would be 5 pi over 4 is a positive angle that's coterminal with negative 3 pi over 4. And if I subtract 8 pi, I'm going to get negative 11 pi over 4. Really need to get used to doing that. Two pi is in your notes that's 360 degrees. Once around the circle is 2 pi radians. This is in radians, so you have to have your answer in radians. Yeah, we have an example of this in our notes, the same exact thing. Okay? You could have converted to degrees and done it. Did anybody do that? I'm sure somebody did. Yeah. Yeah. And then you'd have to add or subtract 3 and then convert it back. Your answer has to be in radians. Yep. You need to get used to this, though. You really do. Because we need to understand, we're going to have to understand the unit circles real, well, we're going to start working on that after tomorrow. So that knowing that once around the unit circle is 2 pi, it's very important, this chapter. And having answers in these forms are going to be all over the place. We're going to be graphing stuff, and yeah, it's going to be something not on your calculator. You're going to be doing it by hand. Okay, name the reference angle for the following. Reference angles. Reference angles are always with the x-axis. They are here. Let's make a little bow tie. Here, here, or there. Now, I didn't make them any particular size for any particular reason. It's just that you have to have them with the x-axis. They're never here up in those spots. They're always by the origin and with the nearest x-axis. So 195. If I draw 195, I'd be into quadrant 2. How far? Yep, 15 degrees. 15 degrees is your reference angle. For 110, you're into quadrant 2. How far did it take you to get back down to here, which is 180? It would be 70 more degrees. That's your reference angle. 348 lands you past into quadrant 4. If I was trying to figure out this angle, which is the reference angle measure, I would need to take 360 minus 348. The previous one was 180 minus 110. And the one before that was 195 minus 180. All right, so what's this one? Okay, 5 pi over 6, the reference angle is pi over 6. And this one's pi over 4. Now, I bet you did it with converting, right? You got to go back to the original form. If you give me degrees on your paper, it's going to be wrong. Okay, so you have to know 5 pi over 6, if you converted it to degrees, would have been 150. Okay, now where's 150? What's the reference angle here? Yeah, that would be 30, and 30 degrees times pi over 180 is pi over 6. This one we're going to start to know starting this week. Pi over 4 is 45 degrees. And if you did negative 7 pi over 4 and converted it to degrees, you would have had 7 times 45, negative 315. Okay, and then you could have said, okay, I went all the way into here, and this way 45 degrees to get to there. Then I'd have to convert it back. 45 degrees times pi over 180 gives you pi over 4. I gotta be honest with you, these are the easiest ones to know the reference angle, because that's 30 degrees reference angle, that's 45 degrees reference angle when it's pi over 4 anything. Yeah, it's kind of easier than the other ones, if you want to know the truth. All right, if the minute hand of a clock is 7.5 inches long, that would be the radius of the minute as the minute hand. Okay, now if you got a clock, it says how far did the end of the minute hand travel from 9 to 11? Nice, lovely circular clock. Sorry about that. And we got 10 and we got 11. Well, if that's the minute hand, what's it got to do to go from 9 o'clock? So this would be the hour hand. This would be the minute hand. And it's got to go, boom, and then it'll be here, right? And then it's got to go around again. And then it'll be there. The hour hand will move. So how many times does the minute hand have to go around? Okay, 2 revolutions, right? They went around twice. All right, 1 time around, how far is it in radians? You guys know it's this formula has to be in radians. Now, I bet you can think about it not in radians at the moment, but you're right, 2 pi. 360, another 360, right? which is 720 degrees it traveled. So let's convert that to radians, because we have to have our theta in radians. All right, what's 720 divided by 180? So we have 4 pi radians. That is our theta. We're going to use S equals R theta. So S equals the radius 7.5 times 4 pi. And that will be in inches. (94.2 square). Oh no, not square, it's just unit length. 94.2 inches. Big clock? Ah, that clock's bigger. Oh yeah. Yeah, it's going to how far it traveled around the outside. Yeah. No, it spun twice. Is this the minute hand? It didn't ask about the hour hand. The hour hand would have only gone 60 degrees. Okay, so pay attention on the quiz whether you're doing the minute hand or the hour hand. Pardon? The hour hand can be used as sort of, well, it doesn't go all the way out. The minute hand's more of a radius than the hour hand, but if you were doing the problem, you still would use that as the radius. Because you could just think of it, you see how there's an inner circle in there, basically, if you did towards the edge of the numbers, then the hour hand would kind of be like a radius of the inner circle. All right? So either way, use the hour hand or the minute hand as your radius, and then, okay. All right, the terminal side of theta in standard position contains the following point. Find the exact values for the 6 trig functions. All right, -3, -2 would put me in quadrant 3. It's like this is the point, -3, -2. The x value then is -3, the y value is -2. You might want to think about that being theta, your reference angle right there. If you want to find it, it's actually just the reference angle. Theta actually went from this positive x-axis all the way into here. But we use this to find the 6 trigonometric functions of theta. So what we have so far is we have an x value of -3, we have a y value of -2, and then we need to find the r value, which is here. So that's going to be the square root of -3 squared plus -2 squared, which I don't need to worry about those negative signs, but I get the square root of 13, and that's your r. All right, now you can use it to write the 6 trigonometric functions of theta. I think I'm gonna rewrite these a little separately just because they're so, it's hard for me to squeeze it in there. So if I did opposite over hypotenuse, that'd be -2 over the square root of 13, or of course you could remember it, it's y over r. Before I rationalize that, I'm going to write the reciprocal function, which is the cosecant. That'd be -square root of 13 over 2. And then I would maybe rationalize this one now. That'd be -2 square root of 13 over 13. Okay, now I'll do the cosine of theta. Adjacent over hypotenuse, or x over r, -3 over the square root of 13. Before I rationalize it, I'm going to write the reciprocal function, which is the secant of theta, -square root of 13 over 3. And then I'll rationalize this, -3 square root of 13 over 13. Finally, the tangent of theta is just, oh, those are easy. Let's just do that. Opposite over adjacent, that's going to be 2/3. And then the cotangent is 3/2. Okay. 22. You are told that the tangent of an angle is positive. Where is the terminal side of theta, or where the terminal side of the angle? Are you limited to just one quadrant, and why? Well, where is the terminal side? It would be in quadrant 1 or 3. Why? Well, tangent of theta is y over x. In quadrant 1, that would be positive because y is positive and so is x. In quadrant 3, y is negative and so is x. X is negative as well. And a negative divided by a negative is positive. That's why. And I don't want you to write because Ms. Heimer said all students take calculus. You remember that way I said all of them are positive in quadrant 1. Sine is positive in quadrant 2. Take tangent is positive in quadrant 3. See calculus is cosine is positive in quadrant 4. Okay, so if you were to write which trig functions, so here sine is positive, the rest are negative, which means the cosecant is also positive. In this quadrant, the tangent and the cotangent are positive, and in this quadrant, the cosine and the secant are positive. And in this quadrant, all of them are quadrant 1. All right, I think that was one more question here. Find the area of a triangular shaped piece of land with sides of 60, 40, and 35. All right, I'm just going to make some kind of a sketch here. I have an area of an irregular triangle, or just a triangle in general, was a formula that said 1/2 of. Now, I don't know which side we want to do, but we multiply two adjacent sides. So I got to pick. What angle do you want to find? Because you're going to have to do 2 steps for this problem. We got to find an angle using the law of cosines. Okay. Let's find cosine C. All right, let's find the angle C. To find the angle C, remember your pattern? If you're going to be using these numbers, which means I will use those numbers in my area formula. And I got to find angle C now, so I can fill it into the area formula. The cosine of C would be adjacent leg 40 squared plus the other adjacent leg 35 squared minus the side opposite squared all over 2 times the product of the 2 adjacent sides. When you type this numerator in on your calculator, you get negative 775. And the denominator is 2,800. I just did it last hour, so I just happened to remember the numbers. Okay, now we would do what to get the angle? Hello? Get an angle? What do you do? Second cosine. Guys, we have to be able to do this. Second cosine, negative 775 divided by 2,800. At least that's how I do it. I write the fraction out. If you just get a decimal, you're going to have to go out like four or 5 places. Are we having trouble with this idea right now? No? 106.1 degrees. That's the angle I'm going to put into my formula now. And I'm going to do 1/2 40 times 35 times the sine of 106. I type it right? You guys get 672.5-ish? Does anybody find a different angle? Does anybody do this? And this is in square meters. You did the angle C. Did anybody do angle the other two angles and one of the other ones before I went over it? No? Well, if you did, it comes out just a touch different on the decimal because of different points of rounding. We rounded twice in the problem. Okay, that is the quiz preview. Be ready for your quiz tomorrow and the homework check. So if you would like to ask me questions on book assignments, I'm just going to stop recording and